All right, I'm going to try and get a few of these problems in before I go eat lunch. So this, I'm going to change it into a big cube root here, 3k over 9k to the third. When we simplify, this gives me a big cube root. That turns into a 1. That k is gone, so just a 1 on top. The bottom turns into 3, because 9 divided by 3 is 3. And then with 1k going, that turns into k squared. So seeing as though I have this, which, by the way, the third root of 1 is just 1, so I can put a 1 there. And then the third root of 3k squared is the third root of 3k squared. So I'm going to rewrite this over here, because it needs some more room. Now, what am I doing? I'm trying to get rid of this radical in the bottom. Can't have a cube root down there. So we're going to multiply the third root of something. Now, with 3's, we have to deal with the fact that 3 to the third power, since we're dealing with cube roots, is 27. So what would you multiply 3 by in order to get 27? Well, you multiply by 9. 3 times 9 is 27. So there's 9 there and a 9 there. K to the second. I need k to the third, so I can take the third root of it. So what would give me k to the third down here, which is what I want? Well, another k. So you're going to multiply this 1 over 3k squared right here by the third root of 9k over the third root of 9k. What that does is it gives you the third root of 9k over the third root of 27k to the third, which is what we need. Now, we can simplify. Up top, we're leaving at the third root of 9k. Our bottom should not have a root in it. So the third root of 27 is 3, and the third root of k to the third is k. That's it. All right, that's going to be my answer right there. Go ahead and trim that off. Put this here. That's my answer. Okay, now let me drop it like it's hot real quick. All right. Now these have 2 variables in them. So we have to make sure that we take care of that. Now, 13, I'm going to go ahead and show you what you're doing on it, but you're going to be okay because we've done something similar. So I'm just going to treat this as if it's one fraction inside the fourth root. Hopefully you can look at it and see that it's not that bad of a problem, that we've done something similar to it already. Because the end of the thirds are gone, the end of the thirds are gone, and I can simplify this. 2 over 50, that simplifies down to 1 over 25. So you're going to take this 1 over the fourth root, 25, which is also 5 squared, and you are going to multiply this by the fourth root of 25 over the fourth root of 25. Now, the reason I'm saying that, ladies and gentlemen, is because 5 to the fourth power is 625. And if you have 5 squared times 5 squared, that'll give you fourth root of 25 over fourth root of 625, which is also known as 5 to the fourth. So our denominator is now 5. Now, you might be looking down at the answer key, and why don't we even check out the answer key, because there's a good chance that our numerator is not the fourth root of 25. So let me go ahead and do this. Scroll down here and look for number 13. Number 13, it is ideal. Cool, I didn't know if they changed it or not. Either way, that's going to be our answer. So we're going to have the fourth root of 25 all over 5, and that's our answer there. Now, last problem I'm going to show you on this video. It's going to be a big one. Here's what we have. We have the third root of 16x squared y to the fourth. Okay. We have to get rid of that. We have to make sure that is a number that we can take the third root of. Now, 16 is actually 2 to the fourth. That doesn't help us very much. Just dropped my phone. But we do know that 4 to the third power is 64. That's going to help us out immensely. So that's what we're going to start by doing. We're going to multiply, this is the third root, to get 16 to turn into 64. We want 64 there, so we can take the third root of it. We have to multiply that by the third root of 4. So 4 and 4 there. Now, can we take the third root of x squared? No. We can take the third root of x to the third, and we just need another x. So we'll put an x there and an x there. Can we take the third root of y to the fourth? No. We can take the third root of y to the sixth, though. In order to do that, we would need 2 more y's, so y squared on top and bottom. All right, so this is what it looks like on bottom. We take this times that, and we get that. Great. Up top, the 2y is just going to hang out. So it's going to be an ugly looking answer, but that's okay. Our numerator is 2y, and then I have the third root of 4xy squared all over. Now, what's the the third root of 64? That'll be 4. What is the third root of x to the third? X. And what is the third root of y to the sixth? Y squared. Okay. There's your answer. Thank you very much for following along.